Okay, we are starting a new section today, 7.3. Okay, and our learning target for this section is to study functions involving the natural base e. This is going to be very similar to what we've done in 7.1 and 7.2, but we're introducing a new number, and I always feel silly saying this, but it's the number e. And it's very similar in many ways to the number pi. So it is called the natural base, and that'll be more clear why we call it that later. And it's an irrational number, just like pi. And to remind you, an irrational number is one that can't be written as a fraction, like a rational number can be written as a fraction. And it doesn't, as a decimal number, it doesn't repeat or end, it just goes on forever. And this is, it's an irrational number where, and this is kind of like the definition of it. It's a definition that's written in formula form. This is how we calculate the number e, and we do it as n approaches positive infinity. In other words, as n gets larger and larger, this approximates the number e. Okay? And so pi, we use 3.14, and e is a number that's very close to 3. And it's also has a button, its own button on your calculator, just like pi does. And I think they used the letter E because of the mathematician who named it. His name was, I think you pronounce it Euler, but it started with an E. So we're going to use this number E just like we use other numbers. In the first problems, we're just going to simplify. Alright, and so we're just using properties of exponents here. And just to get you used to thinking of E like we do any other time when we multiply and we have the same base E, we add the exponents. So we're just going to end up with e to the 9th power. Okay, similarly, when we divide, we can divide the numbers. 18 divided by 2 is 9, and then we subtract the exponents. So we'd end up with 9e to the 2nd power. One more example. Alright, so remember anything in parentheses has to be raised to this power. So we would have 4 squared, and then we would multiply these to get e to the 6th x. When you have a power to a power, you multiply. So our final answer would be that. Okay, now we're also going to practice using a calculator. So if you have a calculator right now, go ahead and get it out. So e to the negative 2 power, we can just enter in the calculator. Now, on some calculators, you have a button that has a lowercase l and an n. And oftentimes you do second LN to get your E button. And when you enter the E button, it'll give you parentheses, and you just plug in -2 for the parentheses. So you should get a number approximately, and we're going to carry a few decimal places here. Okay. And do it again and raise it to the 0.03 power. Okay. So there will be times when you're actually just going to enter that in the calculator. Now, we can use the number E in our exponential growth and exponential decay model as well. So it looks a little bit different if we use the natural base in an exponential function. But it's really the same. Alright, so remember when we just did it before, we had AB to the x power. And this time our B is going to have an E in it. So our A value is the same, and our rate of growth or decay now is going to be up in the exponent spot. Okay, so if we know, our A value is going to be greater than 0, and if our R value is greater than 0, so that number up there is positive, is what that means, then we know it's exponential growth. Okay, our A value is positive, and this time the R value is negative. Then we know it's going to be decay. When we did it previously, the R was either greater than 1 for growth or less than 1 for decay. Alright, now we're going to graph these just like we did in the other sections. So let's look at an example of graphing. Alright, so this time our R value is 0.06, which is positive, so we know our graph should look like growth. Alright, but you can make your XY table just like we've been doing and plug in 0, and if I plug in 0, I'd get e to the 0 power, which is always 1 times 2. Okay. If I plug in the number 1 for x, I'd get 2, and then I'd have 0.6 times 1. Then I'd have 2 times e to the 0.6, and we're just going to enter that in the calculator, and we're going to round it. It's approximately 3.6. Okay, we know this is going to be growth, so we have an idea in our minds what growth looks like, I hope. So we'll plot these points, 0, 2, and then 1, 3.6. Okay, and then remember the x-axis is our asymptote. Just like before, we haven't moved it up or down. So we have to approach this x-axis but not cross it. Alright, and then we're going to do domain and range. The domain is all reals. And this time the range, the y values go very close to 0, and then they get larger, but they can't equal 0. Alright, let's try another graph. Alright, this graph has some transformations. It's going to go 1 to the right and down 2. We're most interested in this down 2, because remember, that will move our asymptote down 2. So I like to go ahead and draw in that asymptote right away. So now this is the line that our graph will approach. I kind of missed it there, but won't cross. Another thing on this one is the R right here is negative. So we know this graph is going to show decay. So it should be decreasing instead of increasing. We're going to make our XY table and get some points on our graph. If I plug in 0, I'd have e to the negative 0.35 times 1, and then don't forget to subtract out your 2. So enter this in your calculator and then subtract 2, and I get approximately negative 1.3. Okay, if we plug in 1, do the same thing, but this time we're going to get negative 0.35 times 2, and then minus 2. If we enter this in the calculator, we get a close number, negative 1.5. Alright, then let's plot these numbers. 0 and a little bit past negative 1. And then this one goes, these are very close together here. Oops, I put this at negative 1, I'm sorry. It should go at positive 1. I knew I had made a mistake because it was showing growth instead of decay, and I knew it was decay. So decay is decreasing in value. And then domain, all reals, you should be getting really good at that one. The range is above negative 2. So y is greater than negative 2. Okay, and then E is also used in an interest formula. And when interest is compounded continuously, you were using different compound periods, and so you used the other interest formula that we had, and this one we're going to use this formula, and it has the number E in it. Okay, these are both in the exponents plot. So remember, P is still principal, the amount that you put in your account, and then R is your interest, and don't forget that it has to be in decimal form. If you get a crazy big number, you know that you probably didn't put your interest rate in decimal form. And T is time in years. I will not expect you to memorize either of these interest formulas. I will give them to you on the test. Alright, so you deposit $3,500 in an account that pays 4% interest compounded continuously. What is the balance in the account after 1 year? So we're just going to plug everything into our formula. Our P was 3,500, and then we'll have E raised to the, make sure to move the decimal place over twice, 0.04 times 1. You just enter that in the calculator, and you should get approximately $3,642.84. All right, that's the end of session 7.3.